So we look at this guy right here. That if I give you 2 points, an x1, y1, and an x2, y2, you can come up with the slope of the line between those 2 points with that simple formula. Simple, yes, but you need to write it down and keep it handy because it's going to be used multiple times in this chapter. We looked at some slopes in general, and we saw that slanted lines, depending on the direction of their movement, either have a positive or a negative slope. We also observed that if you have a slanted line, its equation will have both x's and y's in it. 2x plus 3y equals 19, slanted line. In contrast to slanted lines, ladies, in contrast to slanted lines, there are 2 other kinds of lines, one of which is a horizontal line. Now there are 3 bits of information. These things go together. Number 1, horizontal line, slope is 0, equation is y equals something. Those 3 concepts go together. They ought to be neatly written, bunched together. Horizontal line, slope is 0, equation, y equals something. Likewise, vertical line. Slope is undefined. It's something over 0, so it's undefined. This equation is x equals something. So if you have an equation that just has x's in it, it's got to be a vertical line. If you have an equation that just has y's in it, it's got to be a horizontal line. So those bits of information should be neatly grouped so that you can refer to them when you need to, and you will need to. We talked about different forms of the line. This guy is called standard form, sometimes called general form. Run-of-the-mill form, ordinary, everyday form. That's that guy. We saw that it was handy when you're looking for intercepts. Looking for the x-intercept, let y be 0, solve for x. Looking for the y-intercept, let x be 0, solve for y. So that's one of the great advantages of the standard form. But the one we're going to bank on is this guy right here, y equals mx plus b. The slope-intercept form, called that way because when you solve the equation for y, the slope and the y-intercept are both clearly visible. That's the benefit of the slope-intercept form. Hey, if the equation isn't solved for y, the slope isn't visible. Well, solve it for y. Let's take the equation, solve it for y like you would solve for y anytime. Get the y's on one side, everything else on the other side. Divide by whatever's in front of y. You've solved it for y. And once you've done that, the number in front of x is your slope. The constant number at the end, your y-intercept. That's the benefit of the slope-intercept. We started looking at some scenarios, some minimum bits of information that I could give you, and you could still come up with the full equation of the line. First one was kind of simple. Give you the slope and the y-intercept. Yeah, well, just substitute them for m and b, and you're finished. Second one was a little bit more challenged because it introduced the concept that we probably didn't think of. That's going to give you the slope and a point. The concept that we probably didn't think of is this. You give me a point, you've just given me an x and a y. So if I have m, x, and y, I can substitute into y equals mx plus b, x, y, and m. The only thing I'm missing, b. You can find that fairly easily. So with that strategy, that bit of information, I'm solving for b. Then once I have m and b, I've got the equation of the line. Back to scenario number 1, substitute for m, substitute for b, and I'm finished. The third scenario was I will give you 2 points on the line. And you saw immediately that if I'm given 2 points, a very obvious step to take is, hey, find the slope. we have a formula for the slope that involves 2 points. Y minus y over x minus x, got my slope. Then once you found the slope, you're back to the slope and a point scenario. Back to number 2. Solve for b, and once you solve for b, you're back to scenario number 1. So each of these scenarios works backwards until you have the slope and the y-intercept. Fill it in, you got the equation of your line. All right, on to scenario number 3. What do you call those lines?
Parallel.
Parallel lines. Somebody like to define? Somebody like to venture to define parallel lines?
Two lines side by side.
2 lines that don't intersect. How many would go for that? Wrong-o! And I'll show you why. Watch this. I'm going to show you 2 lines. See the line right here? Runs along the base of the board. Everybody got that line in mind? See that line up there that runs along the edge of the room? Are they ever going to intersect? In fact, this is as close as they ever get right here. Are they parallel lines? So you're going to have to refine that definition just a little bit.